Today we're doing 6.1, identifying and representing functions. So identifying functions from mapping diagrams. It says a function assigns exactly one output to each input. This is the most important part of this lesson. The value that is put into a function is the input. The result is the output. So what you put in is the input, and what you get out is the output. A mapping diagram can be used to represent a relationship between input values and output values. A mapping diagram represents the function if each input value is paired with only one output value. All right, go to the next page. All right, so for some examples, this is only one arrow can branch off an input. So it means one of these arrows can only come off each of the input numbers. If the input numbers are on the left, output on the right. So if we're looking at example A, there's only one arrow coming from each number. If so, it is a function. Okay, and the reason, each input has one output. Okay, if we look at the second one, 0 has one arrow, but 2 has 2 arrows from it. So this makes it not a function. Not a function. Okay, reason for it not being a function is input 2 has more than one output. All right, so to recap, if it has each input has only one output, then it's a function. If it has more than one output, then it is not a function. Okay. All right, let's look at the next one. 7 has one arrow, 8 has one arrow, 9 has one arrow, 10 has one arrow. But what you notice about the output is that 8 and 9 both point to 1. That is okay because each input only has one output. Okay? It's okay if different numbers have the same output. So this one is a function. Because each input has one output. All right, let's look at this one. We have one number, and it has 1, 2, 3, 4 outputs. So it has more than one output, so this is not a function. Okay, so input 3 has more than one output. Okay. All right, next page. It says identifying functions from tables. So it says relationships between input values and output values can also be represented using tables. The values in the first column are the input values. The values in the second column are the output values. The relationship represents a function if each input value is paired with only one output value. So let's look at the x values. X values, just like we've been dealing with before, x is in the table are on the left, y's are on the right. X is the input, y is the output. All right, if any of the x's repeat the inputs, it is not a function because the input has more than one output. So, if any of these numbers repeats, then it is not a function. In this first table, none of the numbers repeat, so it is a function. each input has one output. There are no inputs repeat. Okay, on B, we'll look on any X and Y, do any of these numbers repeat? See 1, does 1 repeat? Yes, right there. Does 5 repeat? No. 4, no. 7, no. So, but we do have one number that repeats, so it is not a function. Because input 1 has more than one output. Or you could say one of the inputs repeats. Input repeats. Okay? Alright. Now on the bottom of your page, we'll look, 53 repeat? No. Does 24? No. Does 32? No. Does 17? No. Does 45? No. So even though it goes to the exact same number to itself, it still only has one output. So this is a function. Each input has one output. Okay, looking at the next one, does 14 repeat? No. Does 8 repeat? Yes. Those two numbers repeated, so it's not a function. 8 repeats. Okay, moving on. Identifying functions from graphs. Graphs can be used to display relationships between two sets of numbers. Each pointed graph represents an ordered pair. The first coordinate in each ordered pair is the input value. The second coordinate is the output value. The graph represents a function if each input value is paired with only one output. So what that means is you have coordinates x and y for an ordered pair. When you map stuff on a graph, x is your input, and y is your output. Okay, so vertical line test. If you draw any vertical line test on a graph, it should only have one point on the vertical line. If there's any vertical line that has more than one point on it, then it fails the vertical line test. It is not a function. If it passes the vertical line test, then any vertical line can be drawn and only one point will land on it. It is a function. So, I'm making a line here. Let's make a vertical line. Okay. If I put my vertical line on here, the best I can. Okay, that's about as close as I can get. Wood. That's not a vertical line, though, is it? Okay, if I take my vertical line, does any of those hit twice? Okay, right here at 2, it hits twice, and at 9, it hits twice. So since it hits twice on that vertical line, it is not a function. Not a function. Okay. Now reason, Bell's vertical line test. Bell's, I'm going to call it the VLT, vertical line test. All right, so let's look at the next one. Take our vertical line, run it across. You can use a ruler on your paper or your pencil. Hits twice there, hits twice there. So it fails the vertical line test, so it's not a function. Not function. Just put A there. Fails vertical line test. Okay. All right, so if you have input 70 and input 71 have more than one output, so that you know how it fails it. Input 70 and 71 have more than one output. Okay. All right, yours doesn't have. Oh, there it is. All right, so let's move our vertical line down here. Let's go across. Hit it one. More than once at 1? No. 2? No. 3? No. 4? No. 5? No. So this one passes the vertical line test, so it is a function. Okay. Reason passes vertical line test. Passes vertical line test. VLT. Each input only has one output. Next page, ordered pairs. Identify all the x coordinates. If any of the x's repeat and have a different value, then it's not a function. If none of the x's repeat, then it is a function because each input has one output. So, we're looking at this. Here's our x, there's our y, x, y, x, y, x, y, and x, y. So, we're going to look at the x's. Do any of the x's, does 2 repeat? No. Does 3 repeat? No. Does 5? No. 8? No. 9? No. This is a function. Reason? X's don't repeat. Okay. So each input, has one output. All right, look at the next one. Does 0 repeat? No. Does 5? 2, 6, oh, right there. So the 5's repeat. So this is not a function. Okay. Input 5 has 2 outputs. Okay. At the bottom there, it has a little summary. It says on the mapping table, graph, and ordered pairs. That's kind of the order that we went in the notes. It tells you what each one has to be a function, and what has to happen for it to not be a function. That's something to look back while you're using your notes while you're doing your homework. Don't worry about the guided practice. You're going to work on your homework. It is due at the beginning of class tomorrow. Have a good day.